Howdy, my name is Logan Ludewig, and for my EIS oral report, I attended the March 21st Friday student presentations, specifically session 5 mammals, I believe at 2:30 p.m. And I listened to the first three. Those were all I had available. And I apologize for the video quality, but my phone's broken. So this computer's gonna have to work. All right, for the first session, the speaker was Dylan Stewart, a PhD student specializing in zoology, or with his, yeah, about to say, getting his doctorate in zoology, with the title of his research being "Is Anyone There? Resident Conspecifics Influence Behavior over Translocated Desert Bighorn Sheep." So his research essentially consisted of translocating bighorn sheep out to San Antonio area, I believe, from New Mexico. And he just wanted to see how mainly their view shed changes were altered when introduced to a foreign site, mainly their pattern and recognition, and to see how that can be applied to big game hunting. He is very much an advocate. He made that clear. Commercial hunting can be used for the benefit and preservation of species. So he made sure to start with that. But a few notable aspects of his research in particular, just as a side note, he did utilize cameras on their GPS collars, which I believe he stated was a first for translocation research. And he made a big deal out of this because that allowed him and his team to actually view and identify which way the sheep were facing and to get a detail exactly of how they were interacting with the environment, which he did find out that while it was expected that they would settle rather than translocate on the top of mountains, so that way they had a larger view shed, it was actually the opposite. They tended to travel to the top of mountains to view and then travel back down and settle in valleys with less of a view shed. And he said he didn't know exactly quite why. He has a few reasons that he will be testing, I believe, later on in the year. So that was pretty interesting that it kind of went against the norm. By the same token, the second uh, oral presentation was Alexia Engel, and she is a student here at Texas A&M. And I couldn't find her major in particular. I believe it is zoology. Uh, but her research was titled "Rare and Convergent High Elevation Coexistence of Coenolestes and Cryptodus in the Northern Andes." Coenolestes being, I believe, marsupial, and Cryptodus being a placentals. Uh, Either way, a quick summary: they are very similar in their niche, almost exact. They're both insectivores. They both focus on the same kinds of prey. They both have the same activity and times of feeding. Location and habitat are nearly the same, elevation included, and complete niche overlap in pretty much every regard, including reproduction, timing, and scheduling. So her hypothesis was that when introduced to the same mountain range, there should be more differences because of competition, and these differences should be measurable and provable. So her research attempted to find the differences in geographical locations, mainly in comparison with population density between the two populations, Cryptodus and Coenolestes, and they measured the morphological jaw and mandible characteristics because those were of greatest influence, they found out. But turns out the hypothesis was the opposite, and they don't know exactly why that is the case. So it turned out that the more population density between the two, the more focused their niche became, the more similar they became. While when their populations were spread out over an entire mountain range, like Coenolestes was completely over here, Cryptodus was, on the northern side of the range. That's when they diverged and they actually started to develop differences in their jaws, anyways. They didn't measure anything else, I believe, other than jaws and mandibles. Uh, but that's also really interesting. That was probably my favorite presentation. And for my third one, I apologize if I mess up his name, Dr. Taye Adeyonju, Adayonju, forgive me. And he actually has a doctorate in wildlife management with a focus on ornithology. And I believe he is also the head staff director at, I can't remember the university name. And I also was led to believe that maybe he doesn't work at that university anymore, but I could not find an exact location of where he is. Uh, his title was Anthropogenic Habitat and Climatic Factors Determining Bat Abundance, Richness, and Diversity in Nigeria, Potential for Spread of Emerging Infectious Diseases. The purpose of the study was to understand the human effects on bat populations, and hopefully this would provide insight into how we could prevent pathogenic transfer or spillover from bat populations. Uh, a key aspect he made sure to imply, even though this program was over the span of 3 years, included 6 bat families, so a few, dozen species of bat, and 956 specimens trapped over that time. They still can't completely identify what exactly the main cause may be, or details that might be a bit fudged based on the uh, biomes and immense number of overlapping population ranges due to either human or non-human interference. That and the habitat types are incredibly diverse around human populations, cities. But the main thing he found out, the number one key point of interest, was human population density tended to lower or lessen bat populations' total biomass, but the population numbers were much more stable than were expected. We expected or they expected fluctuation, volatility, but it turns out that it was pretty stable, and the populations were greatly more diverse than usually found in natural landscapes. So human populations tended to have greater diversity. So that's just something. And I also found that one interesting. Thank you for listening, and I think that is it.